Hello, my name is Luke and welcome to this PyTorch tutorial series. In this video, we're going to finish off section 12, looking at sequential data. We're looking at a bit of a different text generation task. In the previous video, we looked at basic text generation, how we can use the ideas of a many-to-many or sequence prediction that we covered right at the start in a text domain in order to create a text model, a text generative model. And that was more a many-to-many type like this one here, where we were just trying to predict the next word or next token in a sequence, and then we can use that in inference to try and generate an entire article based on a title, which is what the example we used there. So if you haven't seen that one, go check that one out. In this video, we're doing it a little bit of a different way. We're going to create a question answering bot using a different data set. As per usual, all of the code is available in my PyTorch GitHub repo there. If you're new to the channel, remember to like and subscribe as well. Okay, so what dataset are we going to use this time? Firstly, well, we're going to use actually another one of PyTorch's text classification ones, but we're not going to use it for classification. We're going to use the Yahoo Answers dataset. And we're going to use this one because it actually contains from Yahoo Answers. I'm not sure if Yahoo Answers exists anymore. It's kind of like Quora, where you can ask a question, you get an answer, but it contains a question title and the content, and also the best answer or the voted best answer. Normally, this is used to actually score the answer, right? So can you automatically score the answer? But we're going to use it as a question and answer. So we're going to take the question as our input sequence and get it to generate an output sequence of the answer. So we can have a sort of question answer bot there. So the pre-processing is pretty similar to what we saw before. So I'm going to quickly go through that. If you're not sure exactly what I'm doing, check out the previous video where I go into more detail. So if you want to download it again, you'll have to, or you can use the PyTorch data pipe to do that. Again, create the data pipe and iterate over it for it to automatically start downloading, just as a quick way to do that. We're also going to train another sentence piece tokenizer. So I talked about that in the previous video as well. We're doing that in a similar way as well. Note that this dataset actually contains 1.4 million question and answers. So the AG News dataset we used last time had 120,000 articles. So we've got over 10 times as many data points or examples in this dataset. And so not only will training take longer, but the actual training of the sentence piece tokenizer will take quite a bit longer. But we only need to do that once, and it will save that tokenizer for us. So just uncomment that out and train that. So it'll take a few minutes to do that. Again, I've created another PyTorch dataset instead of the data pipe because I wanted to do some processing, again, just in a bit of a hacky way, just combining the question title and content and doing a little bit of filtering on the question and answer. But this dataset is basically just going to return the question text and the answer text as well. So we can create that dataset and the data loader there. And then we've already got that tokenizer sentence piece model trained. Here's just an example of how to actually load it. Talked about that in the previous video as well, but we're not actually going to use it like that. We're going to use it in the actual data transform like we used in the previous video. So here again, we're going to create our vocab as we saw, loading this time the Yahoo Answers vocab that again we obtained from the sentence piece tokenizer. We've also got our specials as well. However, this time we have a few extra ones that we've created. So previously we had the start of sentence and the end of sentence token to tell our model this is the start and this is the end of the sentence. But here we have kind of two pairs of that. We have a start of question and an end of question, and a start of answer and an end of answer token. So I'm going to be using that to sort of flag to our model, this is the start of the question. Okay, the question has ended now. Start of answer. Okay, now I'm expecting you to provide an output and response. And then we have the end of answer saying, okay, this is the end of the answer. And we're going to expect our model to produce an end of answer token, just like it produced an end of sentence token in the previous one, to flag to us that, okay, my response is finished now. Okay. So again, we've got two transforms here. We've got two because we're going to process the question and the answer separately. They're pretty much the same in terms of what they're doing. We have our sentence piece tokenizer. It's the same tokenizer, same vocab, except our start and our end tokens are going to be different. So the start token I'm adding at the beginning is going to be the start of question for the question, end of question for the question, and then we're just basically changing that around for the answer. So I'm going to process them separately so we get those tokens in the right spot. Our model is going to be pretty much exactly the same as the previous one. We're using LSTM still. Again, we have our embedding with our LSTM, multiple layers, and we're going to have our output. Again, we're doing classification over all the vocab tokens, and we're going to pick or sample from the distribution once we've trained that. So really, that's the only main difference here, is that we're going to have this question and an answer. When it comes to training, there is one sort of majorish difference, is that we're going to actually pass the question tokens into our model first, right? And while it's processing the question, we're not going to do anything with the outputs. So previously, we had the input tokens and we sort of shifted them along, and then for every time step, we were trying to predict the token at the next time step. But while we're processing the question, we're not going to do any loss. We're not going to calculate any loss while it's processing the question, and only put the loss when we're calculating or trying to predict the next token for the answer. So that's why what we're doing here is similar to this many-to-many. So we're going to put in the question one token at a time. It's going to be much longer than 3, but we're not going to calculate or expect anything on the output. Only when we generate the answer are we going to do that. We are going to be feeding in the answer as well. So here you should kind of imagine there are extra inputs here. So we're going to be feeding in the previous token for the answer as well, like we did with the next token prediction generating our article. So let's just see how we do that here. We've got our question and answer text, transform them separately, put them on our device. For our answer only, we are going to do that shifting. So we have our input tokens, all of them except the last one, and then we're going to take our answer tokens and shift them across, because again, we're going to put the in this answer text tokens, we're going to have at the very start of all of them in the batch, we're going to have the start of question token, right? And then we're going to get it to, at that time step, try to predict the first token of our answer sequence. Right, so that's why we've shifted that along. Again, if you're unclear, I recommend having to look at those previous ones. I explain it more in there. Okay, so when we're actually passing it through our model, we need to initialize, again, the memory buffers, and we pass those into our model along with the question tokens. Note here, I'm ignoring the output of the model, and I only care about the memory buffers, right? So we basically fill up the memory buffers. Our model is processing the question, trying to understand, extract important meaning from that, and then we're going to pass those memory buffers from the LSTM to the model again at the next stage, where we're now going to get it to predict the answers. So the very first token in this sequence here is going to be the start of answer token, and it's going to try and predict the next token in the answer sequence. So we're not doing next token prediction for the question, only for the answer sequence. So it's pretty much exactly the same as what we did in the previous video, except we have this initial additional step where we're sort of pre-populating the memory buffer with the question information. So if you sort of removed this part here, it's pretty much exactly the same as the previous video, except we're now sort of pre-populating the information in the memory buffer with the question in order to then generate the answer. So that's really the only difference there. So if you wanted to take an input sequence and then wanted to start generating an output sequence once the input sequence has been processed, this is how you do it. So not too much different and not too much else to really cover for that. This data set is very big again, like I said. So I've actually trained this for close to 250,000 time steps. That took a few hours. So don't expect to get your model trained quickly. Again, it's a very big data set. I think with a batch size of 32, it's some 43,000 iterations per epoch. So this isn't actually that many epochs of training. 5 or 6 epochs of training. You probably want to train it for longer than that. Again, our model is quite small and quite simple. Our data set really actually isn't that big either. So we're not expecting amazing things from this model, but hopefully it gives us some reasonable responses to some questions. So like I said, I've already trained this, and we can go right to our results, and I'll show you how we get to inference once we've trained this model. So I've got my test data loader here, and I'm just going to randomly sample some questions and answers. So here's a random question. Is there any program or software to help playing DVDs in different regions? There we go. So that's our question that we're going to put into our model. So what we're going to do first is transform that into our tokens. So here's our tokens. Well, these will be indices here. So these are input tokens. Note that I'm concatenating onto this input token. So the question here is going to have the start of question token and the end of question token. So that's what that question transform's doing. But to prompt our model to now start generating the answer, I'm just going to add the end of the start of answer token, which I'm just doing very simply here by appending an additional 3 onto the end, because the 3 is the start of answer token, right? Just as an integer here. So that's what I'm doing there. So adding that onto the end here as our start of answer token. So we're going to pre-process all of this into our model, and then we're going to start feeding the predictions for the next token back into the model to keep it going and generate the entire answer. Again, we've got our temperature set here. I spoke about that in the previous video. That's just how we control how random our sampling is going to be. So we've got that there, any program or software, those are our tokens, and then we're going to start logging the output of our model after that token. So we just put all the tokens in at once. That LSTM block in PyTorch will process that whole sequence behind the scenes sequentially, but we don't have to worry about that for our purposes. It's like we've just passed it the whole thing at once, and we'll get the prediction for the next token, and that next token will be after the start of answer. So this will be the start of our answer. It will actually produce an output, like I've mentioned, for every single time step, but we only care about the last one here. So we index the sequence dimension, get the last one there, and then we're going to randomly sample. So divide the logits by the temperature, and then we do our sampling to get the next token, and we're going to put that next token back into our model again with the hidden and memory buffers from the previous time step. They'll just go back in, and we keep putting the sample token back in, cap it at 100 time steps, or same as before, we're going to break if we get the end of answer token. So before we broke when we got the end of sentence, but here, because we're generating the answer, we're going to break if our model provides the end of answer token. So let's run this for our question and see what we get. So we've got an end of answer straight away. Let's try and do that again, see if it gives us something different. There we go. It's returned just a single URL that time. There we go. Here's a bit of a better answer. Here's a link to a site for you, and it's just giving us a whole bunch of URLs. There we go. So here's a popular site available on your kind of time. It thinks that it's the best free alphabet. So yeah, just like before, it is understanding the question a little bit and giving us a response that is generally with the same theme. Let's try a different question. Oh, maybe not that one. What is low red temperature? I'm not too sure what that one is. How do I change this color on text in my space? Try the following. Didn't really give us much. Let's try another go. Okay, right click on it and drop it. How many screens are the opposite method you want to go? I can make use. So there you go. It's trying to generate an answer that, again, is the same theme. So hopefully you can see, at least, using this very simple method of having a question, processing it, and using those special tokens, the start of question, end of question, start of answer tokens, to basically flag to our model and to get our model to flag to us what's going on. Again, you can see the probability distribution of the tokens. So it did give us an end of answer token here, but that was probably one of these ones at the start here. It could have kept going. As you can see, there are some tokens that it could have sampled that weren't, 0. So we can play around with this a bit more. Give me the address of a dance bar in Paris. right click on the wallpaper and check out this website. There's a link to the bay. There we go. All right, so that was just a quick one today. I just wanted to show how you could use, again, the ideas we saw in the previous video, implement them in a slightly different way to basically get a whole different sort of behaving model and a model that we can use for different tasks. So hopefully now you got some idea of how you can use these sequence-to-sequence models to implement whatever you want to do. That pretty much is the end of this section. We're not done with language models just yet. We're now going to look at how we can improve upon LSTMs and how we can add something like attention to improve the model's ability to remember longer sequences, and eventually see that we can actually do without recurrent models, but that'll be in a future, somewhere in the future. So the next section is all about attention. So again, if you're new to the channel or haven't subscribed yet, subscribe, check out the GitHub repo, and I'll see you in the next one.